So I really want to talk about intersections between lines. So I'm wondering, does this function L of t that we found in the previous example, right, hit h of, and I had t's in here originally. So h of s is minus 3s plus 4, comma 4s minus 1, comma s plus 7. And I really had t's in there originally. Why would, if I had t's in there originally, why would I change them to s's anyway to do this problem?
The lines might not be the same at the same t, but they can still intersect.
Yeah, right? Like, they don't have to hit at the same time in their progression. You guys see that? If I thought about these as a particle that was accelerated linearly in space, right? If these two paths cross at this point, right? For this particle, right, that point might happen at t is 1. For this other particle, that might happen at t is 7. Of course, those t's are just on different scales, right? You guys see that? So even if they were both phrased in t, I would change one, right, over concern that they don't have to hit at the same spot at the same time.
Is that a 7?
Yeah, but it doesn't know. Of course, if I'm actually talking about particles and not paths, right? Or if I'm talking about throwing a rock at a rocket or something, right? Then they do actually have to hit at the same time. Does that kind of make sense? It's not enough for just the paths to cross. So here I'm just wondering, do these two paths cross? So of course I need a different time scale maybe for the second one. So how would you answer this question?
Still thinking.
Are we looking if it hits or if it crosses?
So I'm wondering, does this path, I suppose I should say, cross?
Okay.
So really, do these two lines intersect in space, right?
Can we multiply them like we did with vectors?
Can you like equal them to each other?
Does it cross?
Yeah, so
Yeah, I was thinking cross.
I might
does
wonder if
cross
they're the
cross
same line, right?
Yeah.
If they're the same line, the slopes would be the same. Can you guys read the slopes off of these? How about this one? The slope here.
Slopes 5.
5.
It's all 5 in LT,
Yeah.
but you have.
Yeah, so this one's all 5s, right?
But the bottom one you have -3, 4, and 1.
Okay, so for h, right, the slope is -3, 4, and 1. Do I gain some knowledge from this information?
A little bit.
Yeah, so these are the displacement vectors on the line, right? And I can even tell you what the kind of starting point is, right? The starting point on this line is
Is 1, 2, 3.
1, 2, 3, and the starting point on h is
4, -1, and 7.
4, -1, 7, right? Okay, so if I know the slopes are different, do I know anything?
You know if it's parallel or perpendicular. Not sure that's the right idea.
Isn't one slope negative and one positive, so they would have to intercept?
That's-
Assuming that there's no bounds?
That's good intuition, right? The
Except the other values can
If we're in
be
three
farther
dimensions.
different. So it
yeah,
could
the
be-
unfortunate thing is that we're in 3 dimensions now, right?
Yeah.
So
You like go under it or over it?
Yeah, exactly.
here are two lines,
I
right?
don't think the slopes tell us.
Certainly these could be like this, right?
Yeah.
I mean, there's lots of ways for two lines to not hit in 3 dimensions. In fact, there are lots of more ways for two lines not to hit in 3 dimensions. So in fact, we're going to have to come up with a word for this, right?
Okay.
But I would know something if the slopes were the same. Does that make sense?
Yeah.
If the slopes were the same, I would know they were parallel, right?
Yeah.
Or the same. So then I would just check, are these the same line or are they different?
Uh-huh.
You guys see that?
So if you set them equal to
So
each other,
the-
they'll be 0.
Yeah, so if you set them equal to each other, you'll get 3 equations that all come out to 0 equals 0, right? Or at least they'll tell you what the difference between the scales is. You guys see that? On these guys, I think we're just going to have to try Sarah's approach of set them equal to each other, see what happens.
Okay.
You guys see that?
Get the first two, then check with the third.
Yeah. So I'm going to come up with 3 equations, right?
Yeah.
You guys see that? I'm going to get 5t plus 1 equals
Negative 3s.
negative 3s plus 4. I'm going to get 5t plus 2 equals 4s minus 1. And we're also going to get
5t plus 3.
5t plus 3 is
S plus 7.
s plus 7.
I
we
also
have to-
have bad
Are we
news
gonna have to
for
make
you,
a
Joe.
matrix or something?
The eraser fell.
You guys saw?
Okay.
You just find what t is.
Yeah, so I could just find out what t is in terms of s, right?
Yeah.
You guys see that? So from this first guy here, what are you going to do?
Subtract the 4. Oh.
Subtract 1.
Okay. Doing that way.
It doesn't matter, right?
Yeah.
Pick 2 of these, solve for t and s, and then what do you do with the solve for t and s?
Plug it into
Plug
the
it
third.
into.
Plug it in the third one, see if it works.
Yeah. So it does it cross x, y, and then does
If it equals.
cross the same point.
Yeah,
Yeah.
exactly.
Yeah.
So, I'm going to do this a slightly different way because the 5s are really convenient. Oh, with that, it'll all be the same. So 5t is minus 3s
Plus 3.
plus 3. And from the second one, you're going to what?
Oh, you can just plug it in directly with that. Well, if you have
Oh yeah, we could just plug it straight in.
Yeah.
So then
Okay,
4.
take this, plug it in there.
Negative 3s plus 3 equals 4s.
So negative 3s plus 3 plus 2 is 4s minus 1. Okay.
I was thinking just multiply by minus and
Yeah, you'll get the same thing in the end.
Doesn't
So
equal.
let's see, I got minus 3s plus 5 is 4s minus 1.
No.
Yeah, that's right.
So that reads like 7s is 6.
Yeah.
So s is
6/7.
s is 6/7.
and it gets progressively more.
Yeah, and then I've got kind of nasty equations, right?
Yeah.
Okay. So what do I do with the s is 6/7?
Plug that into your original.
Plug that in the original and get t, right?
Yeah. So then do it for the top.
Okay, so plug that in here. This information in there gives you 5t is some horrible number.
Negative 18/7.
Negative 18/7 plus 21/7 gives you 3/7. So t is
15 sevenths.
3/35.
Or, okay.
Okay, now what?
It was both.
Plug them in,
third.
see if they're equal.
Yeah, I just need to plug those into the third one. So I got 5 times 3/35 plus 3, and I'm wondering, is that 6/7 plus 7?
Well, 5 times 3/35 plus 3 is 24/7.
3/7.
I don't think so.
Sure.
Probably not.
35.
Yeah.
plus
Okay,
3,
so this
They don't
is
look like they're equal.
24.
3/7
Plus 3
gives you
6/7 plus 7. Yeah.
24/7, which is supposed to be 7 and something.
Which I just said.
Definitely not, right?
Yeah, they don't look equal.
So that
Mine
means
lies higher than the other.
Okay, so what happened? Well, when s is something and t is something, right? You have a crossing, but it's only in the xy directions. So spatially what's happening is you smushed the z out, right? You looked at it straight down, and you found the time when they hit each other. Right? The kind of time from one scale and the time from the other that they crossed. And then you noticed, oh, they're actually at different heights there. So these lines don't cross. So now we need a definition. So what do you call two lines that don't cross?
Hey, whoops,
Yeah,
I
non-intersection.
missed.
Different lines.
The railroad conundrum.
They are called skew lines.
These are skew lines. So skew means non-parallel, non-intersecting in 3 dimensions. Or higher, of course.
Also
Cool.
non-parallel. How would you know if they're parallel?
So I'd know they were parallel if the slopes were constant multiples of one another.
Okay.
So fundamentally, I would look at this slope and read this slope is 1, 1, 1, roughly, right?
And if they were perpendicular, they would equal.
So if they were, to know if they're perpendicular, they need to be
0.
probably intersecting for that to make sense, right?
So if they were intersecting, would they?
So if they were intersecting, then I would dot product their slopes. If I got 0 out of that, then I would say they were perpendicular. Does that make sense? Orthogonal lines in 3 space, of course, kind of makes sense if they hit, but make less sense, even if the slopes are perpendicular, right? Doesn't make sense to call the lines perpendicular unless they hit.
So what do you call the line that is parallel but doesn't hit? Oh, never mind, it's just parallel.
Yeah. Parallel's the same, right?
Yeah. So would parallel be like the second equation would be like 15, like it's multiples of 5. Is that what you're saying?
So you want to see an example of parallel lines?
Yeah.
Yeah.
What it would look like.
Let me